similar polygons. This lesson is all about similar polygons. So here's what you need to know. First, let's just redefine similar. Same shape, but not necessarily the same size. Same shape, not necessarily the same size. Here are the two things that you need in order for a figure to be similar. The corresponding angles have to be congruent. Okay? And also the corresponding sides have to be proportional. That means they have to all be either getting larger or smaller by the same rate. So if we double one side, we have to double them all. Okay, corresponding sides are proportional. A similarity ratio is used to check that. And the similarity ratio is just the ratio of the lengths of the corresponding sides. An example. One side grows by 4. They all must grow by 4. Okay, that's just an example of what that means. All right, making a similarity statement. How do you do that? You find the corresponding angle or side. So, the measure of angle E. Well, here's angle E. I don't have a measure for it, but I do have the measure of angle A, and since they correspond to each other, E must also be 53 degrees. AB, that's this side, is to EF this side. So the two left sides, AB is the bigger one, so big left side to little left side is equal to, AD is the bottom, big bottom to little bottom, so EH. Notice since I went in this direction for these two left sides, I have to also go in that direction for the two bottoms. The measure of angle B, again, I don't have it, but I have the measure of angle F, and since they're corresponding, B must also be 127 degrees. GH, the right side, starting at the top and moving toward the bottom, is the same as CD, so little right side to big right side. FG, across the top from left to right, so BC, across the top from left to right. We've done a lot of work with corresponding so far, so you should be very comfortable with this. All right, defining similarity. How do you define similarity? You check for proportional sides. Check for proportional sides and congruent corresponding sides. Oh, sorry, angles. Proportional sides and congruent corresponding angles. You're essentially checking for the two things up here on our list that we originally said we needed to have in order for the figures to be similar. That's what we're checking for. So AC, that's 18, is to FD, that's 24. So 18 to 24. If I divide those both by 6, I get 3 to 4. Okay? AB to FE. AB is 15, FE is 20. 15 to 20. If I divide those both by 5, I get 3 to 4. So far, so good. BC, this side 12, is to ED, this side 16. 12 to 16. If I divide those both by 4, I get 3/4, and since all three of those are the same, they're all 3 to 4, that means the sides all group proportionally, so yes, these figures are similar. Moving on to the example, it says to sketch. Remember, when we're doing these sketches, they don't have to be pretty, they just have to kind of get the job done. So I'm going to do X, Y, Z. M, N, P. Remember, we have to always go in the same order, start in the same spot, and go in the same order. XY is 12, YZ is 14, ZX is 16. I'm just labeling the sides. MN is 18, NP is 21, and PM is 24. So let's check. Are they proportional? 12 is to 18. Let's check. 12 over 18. They're both divisible by 6, gives me 2/3. 16 to 24. Both of those are divisible by 8. That gives me 2/3. So far, so good. 14 to 21. Those are both divisible by 7. That gives me 2/3. Yes, proportional sides. Explain. Proportional sides. All right, move on to page 2. Using similar figures. So again, we're going to use the similar figures to find unknown lengths in similar polygons. So we're going to find the value of x. They tell us the two figures are similar. X is to 2. As. Now when you go to choose the second ratio, since we're going to use this to cross multiply and we're going to solve, there needs to be no unknowns here. This needs to be all numbers. So I have a 3.2 here, but I don't have the corresponding side here to write the proportion. So I'm going to have to use the two bottoms, and I have to go in the same order. If I said x is to 2, then I have to say 6 is to 5. And then you cross multiply. 5x is equal to 2 times 6, which is 12. Divide both sides by 5, and x equals 2 and 2/5. Okay? Find SR. So now they want us to find this side. So this is the side I want. SR is to 3.2 as, and again, I can use 6 to 5 again. Cross multiply. 5SR equals 6 times 2 times 3.2. And then you're going to divide both sides by 5. And SR is going to equal whatever that is. I don't have it figured out on my paper for whatever reason, but 3.2 divided by 5, and that will be your answer. The golden rectangle. I'm not sure if I can draw this really well for you, but here's the rectangle. Okay. And it says it's a rectangle that can be divided into a square and a rectangle that is similar to the original rectangle. So in other words, I'm going to draw a square over here, and it leaves me with a rectangle. And if I take that rectangle and I draw it here, I can break it up into, let's say, a square and a rectangle, and then that rectangle I can draw here. And I could keep doing this over and over and over, and every single time the rectangle can be broken into a square and a rectangle, and then take the leftover rectangle and you can do it again and again and again. It's a special repetitive kind of ratio, which is 1.618 to 1. So that's the ratio. And we can use that to help us solve various different problems. Example 1. Okay? An artist plans to paint a picture. He wants the canvas to be a golden rectangle with a longer side, 30. That's a key thing. Longer or shorter is going to make a huge difference in how you use this. Are you going to put 1.618 over 1, or are you going to put 1 over 1.618? It's going to depend. So here's what you're going to do. So we have an artist. He has a painting, and it's rectangular, and the longer side is 30. We want to know what the other side should be. So x over 30, and this is the longer side. So out of these two numbers, this is the longer side. So it's going to be 1 over 1.618, because the longer sides have to both be in the denominator in order for the ratios to work. Cross multiply. So I get 1.618 x equals 30. Divide by 1.618. And x equals 18.5 centimeters. Golden rectangle has shorter side length 20. This time that's the shorter side. If you just make a note on the side, it's really easy. The longer side is the 1.618, and the shorter side is just plain old 1. Cross multiply. X equals 20 times 1.618, which gives us a total of 32.4. Perfect. The length and width of the rectangular tabletop are the golden ratio. Shorter side is 40. So that's the short side, which means 1.618 over 1, cross multiply. 40 times 1.618 is 65. So you can use your calculator to calculate those. That will be very simple. Just make sure you note on the side which is the shorter or the longer side so you know how to set up the ratio. Sometimes it goes this way, sometimes it goes this way. Okay? You're going to move on and work on your in-class check, and then we'll go over that afterward.